Hello everyone, this is Omkar and welcome back to this channel. Today we are solving 6 exciting problems from the SOF International Mathematics Olympiad IMO for class 10, focusing on the topic real numbers. They are not just any problem, they test your logic, number sense and the problem solving skills in the way you might not expect. I will break down each question step by step and making it simple and clear. By the end of this video, you will have a solid grip on some key mathematical concepts. Before we begin, here is a quick challenge. Try solving similar problem and drop your answer in the comments. Let's see who get it right. Now let's dive into our first problem on real numbers. Question number 1 is based on fundamental theorem of arithmetic. Question number 1. According to the fundamental theorem of arithmetic, if p divides b square and b is a positive, then option A, b divides b, option B, b square divides b, option C, p divides b, and option D, none of these. First, I will write down the statements of fundamental theorem of arithmetic. The fundamental theorem of arithmetic says that if a prime number p divides the product of two integers, then p must also divide at least one of them. So we have already given that p divides b square. Since we have given that p divides b square and we have also given that p is a prime number, right? P is a prime number. According to the statement of fundamental theorem of arithmetic, p must divide at least one of them, right? But here b square can be expressed as a product of b into b. So according to the statement of fundamental theorem of arithmetic, p must divide b. Okay, so our correct option will be option number C. We can verify this statement with the help of example also. We will take the value of p as a 5 and b as a 10 and check whether this statement is true or not. Okay, so if b is 10, then b square will be 10 square means 100. Okay, and since pi divides 100 and pi divides 10, this confirms that p divides b. Okay, so answer of the question number 1 will be option number C. Question number 2 is based on finding the HCF and LCM. Question number 2, if the HCF of 96 and 144 is 24 into K and LCM of 96 and 144 is 24 into L, then find the LCM and HCF of L and K respectively. Option number A, 2 and 3, option B, 12 and 2, option C, 2 and 12, and option D, 24 and 12. First, we will find the HCF and LCM of 96 and 144 using prime factorization. So the prime factorization of 96 will be 96 can be expressed as a 2 into 2 into 2 into 2 into 2 means 2 raised to 5 into 3. You can verify it later, and we can express 144 as a 2 raised to 4 into 3 square. Okay. So these are the prime factorization of 96 and 144. HCF means highest common factor, and HCF of 96 and 144 will be, so common factor is 2. Here there is a 2 raised to 5 and here there is a 2 raised to 4. So common factor is 2 raised to 4, right? And here there is a 3 raised to 1 and here there is a 3 raised to 2. So common factor is 3 raised to 1 means 3. So HCF is 2 raised to 4 into 3, which is nothing but the 48. Okay. And now we will find the LCM. LCM means least common multiple. Okay. Here in the 96, power of 2 is 5. And here in 144, power of 2 is 4. So common multiple will be 2 raised to 5. And here in the 96, power of 3 is 1. And here in 144, power of 3 is 2. So common multiple will be 3 raised to 2, that is 3 square, which is nothing but the 9, and product of 2 raised to 5 into 3 square will be 288. Okay, so HCF of 96 and 144 is 48, and LCM of 96 and 144 is 288. So from the given we can easily write as HCF is equal to 24 into K is equal to 48, right? And which actually implies that if we divide this 24 to 48, we will get K is equal to 48 divided by 24 means 2. Okay, and LCM is equal to 24 into L, which is already given in the question, and we have find the LCM as a 288, right? So which actually implies that L is equal to 288 upon 24, which is nothing but 12. Okay, so L is 12. Now we need to find LCM and HCF of L and K, that is we need to find the HCF and LCM of 2 and 12. Okay, so HCF of 2 and 12 is equal to, HCF means highest common factor, and highest common factor of 2 and 12 is nothing but 2 itself, and LCM means least common multiple of 2 and 12, and first number that appear in the table of both the 2 and 12 is the 12 itself. Okay, so LCM of 2 and 12 is 12. Okay, so the correct option, that is answer of the question number 2, is option number C, which is nothing but the 2 and 12. Question number 3, which of the following is incorrect? First, the prime factorization of natural number is unique if the order of its factors are same. Second, the product of the least power of each common prime factors in the number is the LCM of the number. Third, product of the greatest power of each prime factors involved in the number is the HCF of number. A, both 2 and 3. B, only 1. C, both 1 and 2. And D, 1, 2 and 3. We need to find the incorrect statement. Okay, so for solving this problem, I will use the 3 definition. Okay, so I will write down it here. First definition is nothing but the fundamental theorem of arithmetic, and fundamental theorem of arithmetic states that every natural number has a unique prime factorization regardless of order. The statement given in the question incorrectly claims uniqueness depends on the order, and hence statement 1 is incorrect. Okay, so I will mark it as a incorrect. So the second definition is this definition of LCM. The LCM, least common multiplier, is found by taking the highest power of each prime factor, not the least power. Since the second statement claims that the least power gives the LCM, it is incorrect. And third definition, the definition of HCF, that is the definition of highest common factor, states that HCF is determined by taking the least power of each common prime factor, not the greatest power. Since the third statement incorrectly refers to the greatest power, it is also incorrect. So statement 3 is also incorrect. That is first, second and third. All three are incorrect. So our correct option will be option number D. Okay. Question number 4 is based on LCM and HCF. Given that HCF of 306, 954, 1314 is equal to 18, find LCM of 306, 954, 1314. Before going to solve LCM of these three numbers, we need to first find the prime factorization of three numbers. So the prime factorization of 306 will be 2 into 3 square into 17. Prime factorization of 954 will be 2 into 3 square into 53, and prime factorization of 1314 is equal to 2 into 3 square into 73. 3. You can verify it later. Okay, so now in order to find the LCM of three number, we need to use the formula for finding the LCM of three number. If we have a three number as a ABC, then LCM, that is least common multiple of three number A, B and C, is given by the following formula. LCM of ABC is equal to product of the three number A into B into C into HCF of three number, that is highest common factor of three number, that is A, comma B, comma C, whole multiplication divided by HCF, that is highest common factor of AB into HCF, that is highest common factor of second and third number, that is B, comma C, into HCF of, that is highest common factor of first and last number, that is A, comma C. Okay, by using this formula we can easily find the LCM of three number. Here we need to find the LCM of 306, 954 and 1314. So it will be equal to product of three number, that is 306 into 954 into 1314 into HCF of all these three numbers, and which is already given in the problem, which is nothing but 18, right? So I will write down 18 here, divided by HCF of first and second number into HCF of second and third number into HCF of first and third number, and all these three are 18. We can verify it here also. HCF of 306 and 954, highest common factor is 2 into 3 square, that is 9 into 2, 18. HCF of these two number will be again 3 square into 2 means 18, and HCF of first and last number will be also 18, since all these three numbers have common factor as a 2 into 3 square. So HCF of all these three pairs will be 18 into 18 into 18. Okay, now in order to find the LCM of these three numbers, we need to simplify this. So we can cancel out this 18. If we divide 306 by 18, we get 17. If we divide 954 by 18, we can easily get 53. I can write this easily because I have already written here the prime factorization of all three numbers. Okay, so now LCM of these three numbers will be 17 into 53 into 1314, this, right? If we multiply 17 into 53, answer will be 901. You can verify it later. 17 3s are 51, 1 5 here, 17 5s are 85, 85 plus 5 is 90. Okay, 901 into 1314. Okay, and we can express this 901 as a 900 plus 1 into 1314. Okay, and so if we multiply 900 into 1314, there will be some answer with last two digits 0 and 0. And if we multiply 1314 with 1, our answer will be 1314. And we can use a option. We can decide our our correct answer by option cancellation method. We have four options. First option with last two digit 34, second option with last two digit 38, third option with last two digit 14, and fourth option with last two digit 28. And here we have already found that. So our LCM of these three number will be some number. There will be some number, and last two digit will be here 00 plus 14 will be again a 14. Okay, irrespective of what number will be here, last two digit will be fixed. and that are 1 4, that is 14. And here in the option we can see that there is only one option with last two digit 1 4, which is nothing but the option number C. So the answer of this question is option number C, 1183914. So by using option negation method, that is option cancellation method, we can easily find the answer of such type of question without actually simplifying or multiplying whole numbers. Now question number 5 is based on rationalization. Question number 5, if a and b are rational number and 2 plus root 3 divided by 2 minus root 3 is equal to a plus b root 3, then a plus b whole bracket square is equal to option A 121, B 171, option C 116 and option D 198. Okay, we can solve this problem by rationalization by multiplying it with conjugate pair. So I will first write down a plus b root 3 is equal to 2 plus root 3 divided by 2 minus root 3, right? Which is already given in the question. Now in order to rationalize, we will multiply and divide with the conjugate pair of the denominator, and conjugate pair of denominator 2 minus root 3 is 2 plus root 3. So 2 plus root 3 divided by 2 minus root 3 into 2 plus root 3 divided by 2 plus root 3. In the numerator it will be a plus b into a plus b, right? So it will be a plus b whole bracket square. I will write down expansion of a plus b square is equal to a square plus 2ab plus b square. Okay, so here the a is 2, so 2 square plus 2 into a will be 2, b will be root 3 plus b square means root 3 square. Okay, divided by a plus b into a minus b. Okay, a plus b into a minus b is nothing but a square minus b square. Okay, and here a is 2, that is 2 square minus root 3 square. Okay, so 4, 2 square is nothing but a 4, 2 into 2 4, root 3 4 root 3, and root 3 square is 3 divided by 2 square is 4 and root 3 square is 3, that is 4 minus 3. So numerator will be 4 plus 3 means 7 plus 4 root 3, and denominator will be 4 minus 3, that is 1. So we can simply ignore it. Now a plus b root 3 is equal to 7 plus 4 root 3. So a is equal to this 7 and this b is equal to what? This 4. So I will write down this value. A is equal to 7 and b is equal to 4. Now we need to find a plus b square, right? So a plus b square is equal to 7 plus 4 square is equal to 11 square is equal to 121, and which is nothing but the option number A. So the correct option of this question is option number A. Problem 6 is also again based on HCF and LCM. 6. If P is a prime number, then HCF and LCM of P and P plus 1 will be option A, HCF is equal to P, LCM is equal to P plus 1. Option B, HCF is equal to P into P plus 1, LCM is equal to 1. C, HCF is equal to 1, LCM is equal to P into P plus 1. Option D, none of these. We can easily solve this problem by using the statement. I will write down the statement here. Consecutive numbers are always co-prime. Since P is a prime and P plus 1 is its consecutive number, so P and P plus 1 are co-prime number, and therefore HCF, which is also called as a GCD also, will of these two number, HCF of P and P plus 1 will be equal to 1. Okay, because we have already studied that the two number can be said to be co-prime if their GCD, that is HCF, is 1, and we also know that consecutive number are always co-prime and P plus 1 are consecutive, so their HCF is 1. Now we can easily find the LCM of P and P plus 1 by using the HCF LCM relation. And we know that HCF LCM relation, HCF into LCM of any two number is equal to product of that two number, and two number are P and P plus 1. Okay, and we already have HCF of these two number as a 1, so 1 into LCM is equal to P into P plus 1, and we know that 1 into any number is that number itself, so LCM of P and P plus 1 is equal to P into P plus 1. Since we have already found HCF of P comma P plus 1 is 1 and LCM of P comma P plus 1 as a P into P plus 1, so correct option will be option C, that is HCF is 1 and LCM is P into P plus 1. And that's wrap up today's video. We explored 6 interesting problems, broke them down step by step and uncovered some powerful mathematical ideas along the way. Now it's your turn. Try solving similar problem and post your answer in the comments. Let's see how many of you can crack it. If you found this video helpful, don't forget to like, share and subscribe to this channel. Your support help bring more exciting math concept your way. We will solve the remaining problem in the upcoming video, so stay tuned for that. And in the next session, we will also tackle another fascinating mathematical concept. Until then, keep practicing and keep exploring mathematics. See you next time.